Right, Jared, you don't have to worry about sharing your video audio. Yeah.
Yeah, don't worry. Yeah.
Right, Jared, you don't have to worry about sharing.
Oopsie. Yeah, okay.
Okay, let me know when we should get started.
Maybe one more minute and we can start. Are you able to share your screen?
Let me try sharing right now. Yeah. I have this external monitor that I'm used to using when I do presentations, but then I'm not looking directly at the camera and I want to look directly at the camera. So it's like, I don't have like the eye, like the coordination. So I'm gonna, let me share my screen.
Yes, it's working.
And how do I, okay, it's advancing through this.
I guess you can start sharing whenever you're ready.
Okay.
We're
live now.
Yes, we are.
All right. Hi, everybody. My name is Sophia, and I'm one of the admissions officers here at the NYC Data Science Academy. And I'm here today to share with you a bit about our school and to introduce you to our programs. Now, for some of you, this is your first event with NYCDSA, and for others, you're already enrolled. So in order to capture the widest audience, I'm going to keep this as high level and as comprehensive as possible. If you have any specific questions, feel free to drop it into the chat box or email me directly or the admissions team at the end of this webinar. So a little bit about our school. We offer individual courses, course bundles, in addition to our flagship bootcamp. Because we want to allow you to tailor your education to both your needs as well as your time flexibility. So the individual courses are professional development courses. The course bundles allow you to take advantage of a bundle discount. And our flagship Data Science with Machine Learning Bootcamp teach you the fundamentals of data analytics and data science from the ground up. And you will emerge from the bootcamp with a portfolio of 4 projects to present to employers. We have a new data analytics bootcamp, which allow those who want to dip their toes into data to do so. And this teaches you data analytics with both Python and with R. And you also will complete a series of projects, including a capstone, but it stops short of data science with machine learning. However, you have the flexibility of transferring into the machine learning courses should your interest in machine learning be piqued towards the end of the program. So you have that increased flexibility to tailor your education and maybe to also figure out your finances along the way. So there's the data science and the data analytics bootcamp. We're the only bootcamp that teaches both Python and R. Python has dominated the spotlight in the past years as the language for machine learning, but R is also very widely used, and it's especially in the life sciences. And to know both makes you that much more competitive and well-rounded when you're job searching. During your stay at the bootcamp, you will complete 4 industry projects, including the capstone. And with the capstone, depending on the cohort, you have the opportunity to actually work on pitched projects from our industry partners. So this allows you an opportunity to make yourself more visible in the data science community, should it be a project you're interested in, or if it's a company that you want to get involved in after graduation. We have very strong job placement support via mentorships, where these are one-on-one private sessions that you schedule according to your preference for the mentors. So we actually provide you the bios of our mentors, and they oftentimes are alumni from our bootcamp. So with these mentors, you actually are able to see how they were able to navigate graduation to securing their job in a chosen industry or a field. And during these sessions, you can review homework, you can review projects, and you can also ask about a certain company's culture, what it takes to interview well, etc. We also have a very involved and engaged career services office that will review your resumes and do mock interviews with you. And also, depending on the cohort, we have coding challenges towards the later stay during the bootcamp. You will have these coding challenge sessions where you will be introduced to, you could say, best practices for how to approach certain types of problems that come up frequently during coding interviews. We have over 2,000 alumni working across the globe, and our diversity is reflected in both our faculty and our student body. And I'm proud to say that we've been highly rated many years in a row in Course Report and SwitchUp. Moving on. For those who are interested in applying for a bootcamp, there are two types of bootcamps. We have the on-site, in-person / live stream versus via Zoom full-time bootcamp, which is 12 weeks long. We also have the pre-recorded lecture full-time and part-time bootcamp. The full-time bootcamp for the pre-recorded lecture one is 16 weeks, and the part-time pre-recorded lecture bootcamp is 24 weeks. So depending on whether you prefer live instruction or real-time instruction, you would choose one or the other. For the on-site bootcamp, you would attend lecture around 9:30 to around noontime in the morning, after which you'll break for lunch for about an hour and 15 minutes, and then you'll return for afternoon lecture, which will again last about 2 hours. And for the balance of the afternoon, the instructors and teachers' assistants will be available to answer any questions you may have. And you are also free to collaborate with your teammates and enjoy a cup of coffee in the break room and just socialize. These are so for the pre-recorded lectures and the in-person live streamed bootcamp, the content is the same. The career services support is the same. The interactivity is comparable as well, because even for the online bootcamps that are not on site, you have live office hours and you have these unlimited one-on-one private mentoring sessions. So you will not ever feel as if you're left alone. And the name that we give our online bootcamp, Interactive Distance Learning, is true all the way. These are the start dates for the in-person live bootcamp. The next cohort begins September 27th. For the part-time bootcamp, the next cohort begins August 16th. The following one is September 27th, and our data analytics bootcamp that I mentioned earlier begins August 16th. The admissions process is straightforward. You submit an application. At the end of that page, you will see a link which will allow you to schedule an interview in the next day or so. You will then interview with either me or Noah Escobar. If all goes well, you will be sent a tech assessment, which you will be asked to complete within 48 hours. You'll return it to us. We'll forward it to our team of data science instructors who will provide feedback. And this feedback will allow you to target the areas recommended for you to review for pre-work before the start of the bootcamp. And if you want to take advantage of this very generous discount, almost $2,000 for the August 16th cohort, make sure that you go ahead and pull the trigger and apply now. Any questions? Let me take a look at the chat. Yes, we'll be sharing a recording of the session. If you go ahead and drop your email into the chat box, then we'll send both the notebook file and the recording to you afterwards.
Yeah.
All right.
Thank you, Sophia.
Sure thing.
Yeah, we can give the stage to Luke so he can start his presentation and share the file. Yeah.
Great. Thank
Thank
you.
Thank you.
Thank you, Martina. Thank you, Sophia. So, hi everyone. My name is Luke Lin, and I'm one of the instructors in the NYC Data Science Academy. So, before I joined the academy, I was a mathematician, and then I decided to switch my career path from academia to industry. And I found that, data science was very popular at the time when I graduated. So I joined the company, and my goal was to be able to, there's always certain kind of choice you can make. You might want to stick to something and become really, really specialized in that particular topic, or you could try to be as broad as possible among all the possible resources. You find the one that you do best. And being an academy, NYCDSA Academy, it has been a very, very good opportunity for me. First of all, we have our corporate cooperators who brought the project and data to our students. Through them, I have learned a lot of what people, during the time when I started to join the company, the data science was still a pretty new field. So it was a very nice experience to see how people work on different data sets, what kind of concerns they have, what kind of factor that they took into account, as well as what kind of tools they use, right? So we know that for very, very technical people, they develop the most sophisticated machine learning algorithm. They have to go with lower level languages like C++, that kind of languages. But even though, because after all, you want your tool to be accepted by the public, so they might go with, say, they always need to provide you the API in either Python or this kind of languages. So as some of you probably already know, that in the data science community, still the most popular languages are Python and R. And other than these kind of more general purpose, analytical tools, of course, we have a database, we have visualization tools, we have a software to build an app, so on and so forth. Like you have like Google BigQuery database, you have a SQL database, NoSQL database, MongoDB, for example, and to build an interactive app, you have to say Tableau and Power BI, so on and so forth, right? So there are a whole lot of tools that we could use, and among data scientists, one of the topics that people always talk about is Python or R, right? And as Sophia mentioned before, we are probably the only bootcamp who teach both of them in our curriculum. So I wonder from the audience today, how many of you have used Python for data science or not? If you have ever used Python, could you give me a P in the chat? Let me just have on. Okay, we have one. Okay, a few. That's how popular Python is, right? And how many of you have used R? If you have used, okay, okay. Also, a few of you. And for people who don't use these two languages, Python and R, okay, great, wonderful. For people who have never used these two languages, if you have used any other languages for data science, let's say for data science, okay, could you also share that with? I see a sauce here. Okay. Any other languages or tools or data science package? SQL, C++, okay, very technical. Julia, okay, SQL, Mathematica. I like Mathematica when I was a mathematician. MATLAB is also very cool. Okay, great. Octave, like a free version of MATLAB. Great, wonderful. So obviously the people audience today, a lot of you have some experience in data science already. Well, the thing is, you don't have to always choose, okay? Especially when we use the open source languages like Python and R. You probably know that Python is good in terms of like it's a more general purpose language. If you need to connect to a database, if you need to build an app, even build a web page, right? To gain access to some external resources, Python is usually more flexible for those, right? And essentially that is why, because people want to use programming language for a whole lot of different things. Python is gaining its popularity in the past few years. R, on the other hand, is more specific. Language for statisticians or data analysts. So if you're doing some specific project on a specific data set and you want to have some deep analysis and generate a really in-depth report, then R might be a better tool because it will give you a lot of tools that Python doesn't have. But the good news, one of the ideas I like to share with you today in this session is, and very often you don't really need to choose, right? For your project, you might have a few different components. Some of them might be better if you use Python. Some of them might be better with R. And it is always the pain to have to decide whether I'm going to use Python or R. What if you could use both, right? And then combine them together. So I want to show you that it's really people in the community work really hard to make sure that the people have the right tools to use and don't have to worry about the technical details and focus what we're good at, right? And analyzing data. So hopefully I can convince you that today. So let me share my screen with you. Okay. So the main app I would like to show you is implemented with these files. And I do want to share one file with you. So I will put into the chat. Oh, I don't think it works this way. Okay, so just give me 1 second.
I have the Google Drive link if you guys want.
Could you please?
Yes.
Otherwise, I'm going to.
I have it.
Okay, great.
Give me 2 seconds, and
So my goal is I'm going to share with you an app. And I also want to, so for people who are interested, I would also like to walk you through how this app is built. Of course, I have to, guide you for a little bit simpler app. So now we see the link in the chat. Okay, you could click on the link, and then it's supposed to.
I think it's the wrong link.
Is it?
Wait a second. This should be the one. The second one. Sorry, guys.
Let me give it a try. So when I click on it, you're supposed to see a weird file like this. Don't worry about it. Just download it. Okay, you could just click the bottom here to download. Okay, so it should be there, and you could just open it in your. So I'll just go to the download folder. Just go to the download folder and double click this file. It's going to be opened up in the browser. So I just want to make sure that everyone can download this file and then can open it in the browser. And I'll come back to this file very soon. The app I would like to show you is this. By the way, these are R scripts. So that's why we have extension .r. And by default, to open an R script, a good way to open it is to just use the R Studio. So as you can see, this is so-called the integrated development IDE, integrated development environment for R. It's designed specific for R. So so here I have an editor that I could add my script. And then, for example, just to quickly show you how this is. So this is an editor, right? So I could put my code here, and I was to do 1 + 1. Okay? And then if you execute a line of code, the result will be, it can be seen here. Right? Just a very quick introduction what this is about. So instead of just 1 + 1, we could of course edit a much more sophisticated code that does more than just 1 + 1 = 2. And this is a code for an app. I'll show you how this works a little bit later. For now, let me just show you what this app is about. So I will run the app. Okay, it's going to take some time because it download data and then show the result here. So this is an interactive app. So if I change things, the output, the graph here is going to be different as well. So what is this app about? So this is the COVID-19 data from the COVID-19 test data from the New York State. So in New York State, we have people do the COVID-19 test every day, and then we might want to track how good or how bad a situation is, right? And from here, I allow the user to specify whether we want to see the full data, the result from the full data set on the from the New York State, or we could just focus on one of the, say, Albany. Okay, then the curve will be different, right? And I could also choose the date. I mean, the range of the graph I would like to inspect. So that's the widget here. And also if here we have the visualization to see the trend of the, this is actually a positive rate. This is actually a positive rate to see among all the people who took the test in a certain day, how many of them are actually positive. So this is actually a positive rate of the test. And we could also see, so besides the visualization, we could also embed the table. Okay, I'm sorry, I think I have a little version issue here. Let me quickly change my code. Yep. So now it's good. So so if you could of course look at the visualization, or if you want to take a look at the raw data, if user might, so if we expect that the user might want to take a look at the raw data, we could also embed it here. So these are the new tests every day and the new positive every day from the New York State. So this is just a way we could. So for example, you could imagine if you like to monitor something, like before the talk, we had an opportunity to interact with some of the audience who are monitoring the stock price. You can imagine that this kind of tool could be helpful. So that's the app I would like to share with you today. And I will also discuss why I mentioned that, like interface or a tool like this allow us to combine the languages different languages that we could use. So let me first put this away. Okay. I will show you how this kind of app could be built. And it's super, super simple. Let's see. So I would like to turn this off as well. To start with any project, okay, you would like to have a new folder. You like to have a new folder. Let's see if there's a question. Okay, let's have a new folder. Okay. And let me call it, I have a Shiny workshop, so I'm gonna call it Shiny demo. Just make them a little different. And then in my R Studio, I could change. So this is just like your, how do you call it? Like the file explorer, right? So we could navigate back to the desktop, right? And then go to the Shiny demo, which is an empty folder at this point, And then I can create some new file. To build a Shiny app, essentially we need two components. One is called UI, the user interface, and the other is called the server. So both of them will be an R script. So let me just create one R script, right? So I went to the file and then specify I want a new R script. That gives me the first file here, and I like just to save it. You save it. I'm going to save it in the Shiny demo. Shiny demo. I'm going to call it UI.R. I'll explain what UI is about very soon. Okay, so that's a UI.R. And once you have that, you will see in the lower right corner that this file has been created and saved, right? And I need another one, which is called the server.R. So I'm going to save. I could either click on this, right, or go to the file and do save as. So I could do server.R like this. So back to this note. If you, I don't really have the time to walk you through RStudio today, unfortunately. So if you're interested in that interface, which is definitely the most popular interface to write R script. So you could go to a very nice guide that RStudio provides us. In fact, this is, this is a guide for Shiny. This is a guide for Shiny. And they would guide you how to use RStudio to write your Shiny app. And so we have created the project folder and have this UI and server in it. And just as the names indicate, UI is for the user interface. So when you build your user interface, you probably want to have a different widget in different place of your app. So the visualization, the line chart should be at a particular position, and the table you would like to be in a different position. So how do we specify that? Well, we specify all those in the UI. So you define what your user will see in this UI.R. And the server.R on the other hand, will process this user's request. So when users say, I want to see the data from Albany, then the server will catch that and then return the result from Albany only. So that's what server does. It processes the user's request. Okay. So to build a Shiny app, at least we need these two parts. Okay. And then inside these two files, we need to have some code to indicate what should be done and what should be, placed where. So in the UI, this is like a minimum code that you need in a UI. So you could just copy and paste it in your RStudio or whichever editor you have. Okay? But if you look at what we have here, we're going to build a Shiny app. So we need a software that, facilitate a Shiny app. So we're going to use the Shiny dashboard package, first of all. And this Shiny dashboard package provides us not just the software that launch an app, but it also provides us a lot of templates. So the one I'm going to use is this so-called Shiny dashboard template. And in the Shiny dashboard template, we could have a header. So this is a function where we specify what the header should be. Okay. And then this is a sidebar and the main body. So obviously this template comes with a title, a sidebar, and the main body. And it already gives us structure, so we don't have to do everything from scratch. Oh, I'm sorry, I pasted this in the wrong place. Yeah, obviously this is, specifying where should go where, right? What should go where. So instead of having it in the server, it's supposed to be in the UI, right? What the interface look like. And then on the server, the minimum we need are these. So if we go back to the server.r and place it here. So this is like the core machine that launches a Shiny app, okay? And this is just dashboard, give us the template. So obviously, as I mentioned, that the server will process the user's request, right? So obviously, it has to take some input from the user and then generate some output. And our Shiny will formulate this as a function. I'll show you how these functions could be used very soon. But from here, we already have a it's like a minimum app that we could have. If you just paste the code we have in the HTML file in the UI.R or server.R and try to run this app. Okay, we already have an empty app here, okay, which does come with a sidebar, right, and a main body. The title will be here, as I'm going to show you very soon, and already there's some functionality implemented here. Okay. So of course, if you want, you could explore other templates. Maybe they will provide some other kinds of the functions for us, which will be nice. But today I'm going to show you just the shiny dashboard. Okay, let me quickly check if there's any question. It seems that it should be done in the UI. Thank you very much. Okay, that's exactly what I have to do, what I should have to do. All right, so that's the UI.R and the server.R. And now a very simple question. If I would like to make this my title of the app, where should I paste it? Any guess? UI.R, good guess, right? It should be in the interface, right? I want to place something there. So we could copy this, and then go back to our Shiny app, and it should be in the UI. And if you look at these functions, right, 3 functions, the dashboard header, right? And then where should the title go? It should go to the header, most likely, right? And now if you reload the app, okay, it will ask you to save the change that you have made. And then we just go ahead, save it. And expect an object with no, I'm sorry, I should have done this. Title. And let's give it a try again. Okay, so the title is now the title we want. And that's how simple, I mean, at least if you just want to have some app, that's how simple it is. In fact, for all the other elements, if you want something really fancy, that might be a different story. But for almost, I would say 99% of the widget you want, the Shiny community already have built a lot of simple tool that you could use. Very often what you need to do is just to put the right object in the right place, like what I just did, okay? And then if we want to build some widget, right? If you saw what I did before, I could click on table and then table show up, and then I click on a plot, then the line chart show up, right? So if you want to do that, here are the functions that we need. Here are the code that we need. So let me just copy and paste them to the right place. So this is sidebar menu, which define the sidebar menu we have, right? And if you go back to your code and look at the function we have here, where should we paste that sidebar menu chunk of code into, right? Probably just the sidebar function. Okay? So that's, again, how easy the things are, right? Put them here, and you're going to have the sidebar. But the sidebar doesn't work by itself. When you click something else to show up, right? So we also need that something else, which are the items. So these are like the button to go to a particular tab, and these are the actual tab items. So I'm going to copy this and put them to the dashboard body, right? So from here you're going to see that the text on the bottom will be table and chart. And these are like the ID. The way we identify the bottom and the tab is through the ID. So when you click on this bottom, this tab will show up because it's table and table. And when you click on this one, this item will show up because it's chart and chart. Okay. At this point, I put just 1 and 2 as the content of the tabs. Of course, we're going to make it more sophisticated. But for now, just for demonstration, let's just reload the app. Okay, we see we have a table here, And and by default, it's on the first tab item, which is just one. And if you click on the chart, it gives you the content of the second tab. Okay. Again, if you find the right template, everything's gonna be very, very easy. Let me quickly check if there's any question for now. Okay. Then we'd like to build some real stuff, right? Then we'd like to build some real stuff. So I would like to download the data so I could show the data visualization. And the data I showed you was the COVID data, the COVID test data in New York State. So if you want, you could go to this is the main page where you could see the introduction in the data dictionary here. Okay. But the data source is this link. So you could use this link in different way. If you just copy it and then paste, let me do this very carefully. Okay, paste it here, and a CSV file will be downloaded, which is the COVID test data set. Okay, and I'm not gonna do that, right? I'm not gonna do that. I'm going to simply use this read.csv function. Okay, so hopefully people are familiar with the CSV function. I'm sorry, a CSV file. A CSV file is really just like your Excel file. It gives you a tabular data set, bunch of rows and columns. Okay, so that's a file. If you already know that the link is to a CSV file, you don't need to download it and then read it in. You could just go ahead, do read CSV and pass the link. And the rest of the code are just to to get the right format from the data. The main topic today is not to talk about cleaning data, which is another very interesting topic. But just bear with me a little bit here that we download the data and we're going to use it. We use this data set. Now the thing is that when you download the data, you probably want to use it not only in UI, but also in server. And the problem is by default, if you download something in UI, you can only use it in UI. And if you download something in server, you can only use it in server. If you want to download something that could be shared by UI and server, a way to do that is to download it in another script called global.r. Okay, in fact, a common practice is loading packages that you need should be done in the global.r. Okay, and if you have some data processing, if you do some data processing and you would like the result to be shared by both the UI and server, you should also do that in the global.r. Okay, so the data should be shared by the two files or two environments, and this object that we create should also be shared by both of the environment. And if you look at, so even if you don't really know R, okay, so we know that we have a variable called county in the data set. So we want to know what happened in different county, right? So the data set comes with a column called county. And then the function here is called unique. So what is that about? We want to find the unique counties we have in the data set. Okay, so really this is the collection. So this is a collection of all the counties we have. And now let me copy this and then go to the RStudio to create another file. Okay, I'm going to paste the code here and then save it as global.r. All right. And now I would like to turn this off. So there's a little technical detail that the global will not, global.r will not be executed if you just reload the app. You have to stop the app and then restart it. There's some technical details that if you are interested in R-Shiny, then you might want to take care of that. Otherwise, just a little technical detail. So with the global.r, we will have the data. With the global.r, we will have the data. And then we would like to use the data, right? The first thing we like to create with the data is we might want to allow the user, to select the county that they're interested in. Okay, so we would like to create this so-called so the select input. This is the function that create a drop-down list in the UI, right? So I will copy and paste this to UI right under the sidebar menu. I put it here. Okay, I'll talk about what these are, but now if we run the app, we already see the drop-down menu here, right? And the options you have here are the counties that we collected from the data set. Okay, and then you can see that which county is the title of the widget, just to indicate what this widget is about. Okay, and then these are all the possible choices, right? If you recall that we created this county in the global.r. This is a R vector. R vector. If you're not familiar with R, that R vector is just a collection of values. The collection of values, and we use that collection. Let me move global.r here. So we use that collections to be the options for the users to choose from, and this is again the ID. Just like the ID of the tab before, we need the ID to identify the input. I'm going to show you how that could be used in a little bit later. But just for now, just keep in mind that this is ID. This is a specific identification for this widget. So later, if you want to say, okay, give me what I get from this drop-down list, then you will refer to county. Okay. So that's this part. And besides using the vector we generate in global.r in UI, of course, we might want to use that in the server as well. Okay, so if you look at on the server side, right, we do have this data set of the test cases from the whole New York state, but we might not need all of them. So if the user say, I only want to look at Albany, we would like to just return Albany to the user, not the whole thing, right? So for that, if you want to subset a data frame, you could use this filter function. And inside the filter function, you could specify, I want the county equals to the county that user input. Okay, so all the user input are going to be stored in this input. This is actually a list. Okay, R list. For people who are familiar with R, this is just an R list. And then so everything that users select will be stored here, and they will come with a tag. The tag is really just the ID of the input widget. So whatever users select from this dropdown list, it's going to be saved into input at input. I mean the county input dollar county. Okay, so if you name the name the input widget differently, then you have to refer to the user's choice with different ID. Okay. So with that, we could select the relevant portion or relevant subset from the data set, and that will be a table. That will be our table. Okay, that will be our table. But the R table cannot be presented in the Shiny directly, because this is just some technical detail. Again, the table you see in the front end is not the same table that you see in the R environment. So to make the table something presentable on the Shiny app, we need to pass the table. So we call this table selected, the one that user selects, and the selected table has to be passed to this render data table function just to make it the format that the Shiny can present. So this is what we need in the server.r, right? So inside the server.r, from the input, we got the user's choice. And then we output what we generate to the output. So this T is now the ID for the table that we generated here, Okay, so we're gonna generate this table, but we need to specify where the table should appear in our user interface, right? So we need to specify where the table should go, Obviously, we want it to be under the table tab, right? So instead of just one here, we want the content of the table tab to be the table we just generated there. And how do we do that? Well, if we go back to the note here, we could use this function, a data table output. The data table output here. Okay. So the ID for the table we generated was T. And then we specify that T object is a data table, and we want it to be placed in the table tab. Okay. And just a little technical issue that I failed to update this. So it should be we have to put a DT. Do I have the? Yeah, I need to library the DT package, and then specify I want to use the render table function from DT. So again, I will have to close this app, because whenever I change the global.r, I have to close the app and then restart it. All right, so you see that in the table tab, I have this table now, and I can go to, so as you can see, this is like the earliest data that we have, early March last year. And if we go all the way to the last page, we see the very recent data. So that's how we place a table here. And now if you want to place something to the chart, to the chart tab, which should be a visualization, right? So what we could do is we could create the plot. Okay, with the selected table, we might want to generate the ratio. The ratio is obviously the new positive cases over the total number of tests. Okay, and these are the columns we have in the table. And then we could just do the computation and generate the ratio. And then we got a ggplot function, which is so ggplot2 is personally my favorite visualization package. Not only with R, but among all the visualization tools that I have ever used, I like ggplot2 most. But anyway, so if you're interested in analyzing data with R and do the visualization with R, we have a very nice materials that you could learn from. Depends on how good you are in coding, you could generate more and more sophisticated visualization. But once the visualization, the plot is generated, we have to render. So again, the plot you generate in R and the plot that you could demonstrate on the Shiny app are not the same type of object. It is just, again, a technical detail. So we generate a plot in R, and then we use this render plot function to make it presentable in Shiny. And then that Shiny presentable plot, we call it P. So that will go to server.r. That will go to server.r, which is just another chunk of code. And this output P should be placed somewhere in my user interface. Okay, so that will be a plot output, and then I specify P should go here. And then I didn't change it global, so I think I could just reload the app. It should work. Let me give it a try. Okay, so the chart will have the graph here. So that's a very, very simple app that even if you just read the code, it's pretty straightforward to understand what each component of the code is about. Okay. Any questions about anything?
Yes. So there's Wu Jian asking.
Yes.
Why did you do you to art script
Shiny
file.
app. This is a Shiny app. This is a Shiny app. What do you mean by Shiny web app?
So
So-
basically for the UI and server, did you open 2 new R script files or just a Shiny web app?
Could you repeat that? I didn't quite get it.
For the UI R and server R, did you open 2 new R script files?
Oh yeah, yeah. You
Yes.
could use that. So the reason I didn't do that is because I'm not sure where audience default folder is. So when you do it happened before that when people do Shiny web app, click on that and generate a folder, and people cannot find it. So that's why I want to make sure that everybody can find this. Mhm. So we could check the error a little bit later offline. Okay, there might be some, very often this kind of, I do see an error in the chat, a question about error in the chat. Very often that is just a misplace of a comma or things like that.
And William's asking, can you show the code about the DT again? Or is it?
Yeah, absolutely. In fact, let me just, Martina, can you just share the code with people after the session? Yeah.
Yeah.
We just share the full code to you guys.
If you guys are registered with your email, at the end of the event, we're gonna share with you the scripts, notes, and also like the files and recording.
Yeah.
Yeah.
Okay. So you could follow up, with the recording.
Yeah.
But that's just building a very, very simple app. Another thing I have like less than 10 minutes. Another thing I would like to mention is that with this kind of tools, you could actually put together different languages. Okay. So this is the full the full app that I show you in the beginning of the talk. So to run this app again, let me close the old ones. Okay, this is the one I demonstrated, and then the full one is like this. You can see that the server.r is much more complicated than the one I show you. And if you run this app, there's one thing called notification. Okay, and this is where you could send out notification to a mail list that you maintain somewhere. Okay, we know that R is good for analysis. So if you want to do some analysis on the table and generate visualization, ggplot2 is my favorite. Whenever I need to do visualization, I would like to go with R, with ggplot2. That's no problem. But if I would like to share the result with people, right? For example, I'm monitoring the positive rate, and when positive rate is greater than a certain number, I would like to notify our students or instructor, hey, wear your mask tomorrow because the situation is worse. Okay, things like that. I like to send a notification, but R as a language for data analysis, it doesn't come with a lot of API for me to use the other services. For example, if I would like to send out an email, I might want to use Google API, Google's Gmail API. Okay, and the Gmail API does provide, Gmail does provide us API in Python. You could use a Python code to specify, send the email to these people. You could do that with Python. But it's not that I at least from the official Google web page, we don't really see the R function to do that. Okay, so to send out notification, I need Python. To do analysis and visualization, I want to do in R. How do I combine them? Well, luckily it is possible, right? So I write some Python code here, okay, which allow me to, let's see. Okay, so this is a fake account. This is a fake account that I created to do demonstration. And then this account has, of course, a Gmail, and it also comes with Drive, Google Drive. Inside a Google Drive, I have, I think it's a test. Yeah, okay. In this folder, I maintain an email list. That, so I don't need this for now. Okay. So let's say Luke Lin. All right. So you can maintain an email list, and you probably don't want to create another interface to maintain this email list because the Google Sheet is already very easy to use. and you probably want to use their service. But it is possible that you combine the Google Sheets service and the Gmail service into your Shiny app. So for example, where's my app? Okay, here we go. If I click on this button just to send the notification, okay, so it does the computation, right? Of course, your real analysis could be more complicated than this, but what I did was I just download the most updated data and figure out the positive rate, and then send it out to the email address that I have in this Google Sheet, which is myself. Okay, and then it tell me, hi, Luke Lin, the most recent positive rate is 185%. Okay. And if you like to, and if you, so obviously the email list could grow, right? So if anyone would like to share your email with me, I could take probably 2 in the chat, give me your name and your email address, and then I could send that notification to you, just to convince you that this is not you know, pre-installed stuff. Okay, so we have Raul. Let's do this here, and then Raul's here. Anybody else? No? Then I will just go with Martina. And then oh yeah, we do have one, so I'll go with James.
You can also add mine.
Just to avoid to overdo that.
Yeah, James has one.
Why don't I? For some reason, I have a problem to copy this. Let's see. Okay, and then James. Okay. And then let's go back to here and click again. So you see there are 3 emails that were sent out. So James and Raul, you could tell us whether you received. It probably take a few seconds, but you could let us know whether you receive it. And while you're checking your email, the main thing I would like to share with, the main idea I would like to demonstrate here is, if you look at the survey, so James got it already, that's great. So you could use the tool everywhere, right? So you want to maintain an email list, Google Sheet is your best tool. And you want to use a visualization from R. The ggplot2 is your best tool. And then you want to send a great, Raul also receive it. And you want to send out notification, Gmail is your best tool. So among all these tools, you don't have to choose only one to be used. You could actually combine them into this simple app. So if you're good in R, right, you could put together all these functionalities and build your own workflow. It will make your life a lot easier if you could really put the best services instead of choose the one that you could go with. All right, so that hopefully this convinces you that even with this kind of very simple tool, right, it could actually make your work much easier. All right, so I guess because I talk very fast, I definitely missed a few questions, but that's everything I have to share with you tonight. So thank you so much for being here with me for a little while to look at this to talk about this little interesting topic. And if you don't have any questions, then that's it. That's everything I have. And I would like to go through the questions I missed in the chat, and hopefully I can answer a few of them. Let's see.
Oh, wow. There's one asking, is there a link for the output web page so that other users could access?
So the thing is, the app I show you today is only running locally. And so as you can see, this is like my personal assistant. To actually build an app, like a web app, it's a little bit more sophisticated than what I just showed you. A very simple way is to use the service from RStudio. They allow you to host a very simple app, but that's usually very small. Okay? If you load a data set that is too big, then your app will crash with that. If you're interested in that, you probably want to learn more about Shiny app. From what I demonstrate today, you might not be able to do that easily. Okay, I see.
Jared has a question. So with your own background in mathematics, how much do you really need to use complex math in functions and programs? For instance, would someone who struggle with math have problems building apps in Python and R?
No.
No.
No. Okay. So a very quick answer is if you want to just do coding, if you just want to do coding, you do need some discipline in math. Okay. For example, if you want to compare so for example, you want to compare different states, which ones suffer more from COVID-19. Okay, that's an abstract question. And you want to come up with a number to quantify the situation and be able to compare. You want to do it right. So you want to do an apple-to-apple comparison. So very often that depends on how good you are in quantitative thinking. Okay, but you don't really need the very advanced math for that. Okay, so your critical thinking is important. Some understanding on math, normalization, for example, is important. But if you just want to be a good data analyst, you don't really need those advanced math. However, if you want to be, for example, a deep learning practitioner, then you will have to know some advanced math. So it really depends on what kind of a career goal you have. Okay, you need to aim at different level of sophistication.
Yeah, that is true. I came from a marketing background and I was able to pick up my data science skills. So you don't really have to worry. And if you guys want to join the bootcamp, we have also the pre-work. So it's not something that like you guys have to really worry about.
Right. And I see another question from Fred about smoothing the data. The answer is yes. I didn't show you in the note, but the data you see here, they are smooth. Depends on the window, the filter, the size of the filter. You can make it more and more. You can make it smoother. Okay, if you just use a very small window, then you see that you have, the curve is a little more fuzzy than if you use a bigger window. So the answer is yes. Just I don't have the time to show you the detail of that. Okay. And as soon as you show data in some fashion, new questions will arise. It jumps so fast. Right, that's true. Right. So you want to smooth it, and you probably want to, other kind of weighting, for example.
There's a cute one. He's saying, why is there no Python shiny?
Okay, so there's no Python shiny. If you ask around, people might tell you, hey, there's a Flask, there is a Jungle. I would say that the Flask is also easy. Oh, and nowadays we also have a Dash. So I would say that Dash is probably the closest one to Shiny. It's also very easy to learn. If you want to build an app in Python, then you might want to go with Dash. But I would like to, this is of course my personal sharing, that because I'm so much in ggplot2, so very often I build an app you build an app to monitor data, right? And you want to monitor through visualization. And because I like ggplot2 so much, I want to use a native language to do ggplot2 and app. So that's why very often I will go with Shiny. Yeah. And of course, if you want to go with, so for example, Plotly, which is also a very popular interactive visualization package nowadays in Python, you might want to go with Flask or Dash. So I can't really share with you the code of notification, because that use my personal credential for sending out email and the Google Sheet. So that's something I can't really share with you, unfortunately. Okay.
Yeah.
Oh.
Moving parameters.
Yep. So the idea of making the smoothing parameter interactive. In fact, any numerical parameter can be interactive. It just happened to be the window size in this case.
Other questions in general? So basically, guys, if you register with your own email, you're gonna receive the video, the notes, and
I'll also give the code to people. I'll go, Martina. I'm going to give the code to you, and please also host that in
Yes, I'll share everything tomorrow. So, and if you guys have questions, feel free to ask now because Luke is really nice. And yeah, he's one of the instructors at our bootcamp. So if you guys join, like you'll see him around.
Yeah, you'll see a lot.
Yeah.
At day one.
Questions?
Thank you. So if there's no other question, I think we could say goodnight to people.
Yes.
Yeah, I'll stop sharing and hope everyone have a very nice evening.
Saying if we use the Shiny Web app,
Oh, there was another
same
question.
principle. What do you mean?
Hold on. Let me
William.
check. It's William's question, right? So let me. If you use, it is the basically the same principle. Yes. So if you use Shiny Web App, it's going to create a UI.R and server.R for you. If you also want global.R, you have to create that separately. All right. And well, there are different options, but essentially, that's just the same process.
But yeah. If you guys really like Luke's presentation, maybe we could invite him to present more.
Of course.
Yeah,
My
you're
pleasure.
really popular.
Mhm.
Yeah, we have like more topics and stuff. So feel free to follow our social media. So LinkedIn, Facebook, Instagram, Twitter. So you're gonna be like tuned and know firsthand when we're gonna have our next events. And tomorrow, I think, is the last day for the 10% in our online bootcamp. So feel free to check it out now and schedule a call with our admissions officer. And I'll put a link or an email tomorrow. So check our website. Oh, there's a Q&A. What did you say about Plotly?
Oh, was that in QA? Yeah. So I like Plotly a lot as well. But the thing is, there are two concepts essentially when it comes to data visualization. One is if you want to highlight a finding from visualization, very often you want to make it static. Okay, so you have like a scatter plot, which is the dot on a two-dimensional space, and you want to highlight a particular point. You want to make sure that all the audiences see it, so you want to make it static. And nobody could change that, right? So that will be easy. You could do that easily with ggplot2. But if the purpose is to build an app like what Plotly gives you, it is an interactive a visualization. That means you allow the user to choose what they want to see. Okay, they might want to look at different variable and highlight different points. That will be easy to do with Plotly. It will be difficult to do that with ggplot2, but it will be very easy to do with Plotly. But then it will be difficult for you to highlight any because the user could change, so you won't be able to highlight that. So it depends on the purpose. Okay. I also like Plotly a lot. Just they kind of serve different purposes.
I think that's it. They say
Okay.
thanks, left their emails. Should be fine. So let's call it a night. Thank you so much for being here. Thanks so much to Luke for presenting this interesting topic. And we're gonna see you soon. Bye, guys.
Bye. Have a good night.
Bye.